Hello, everyone. Thank you. Okay, so 1 year more, here we are in OpenSlava. Thank to the organization, to everybody for being here, for inviting me here. And the end of software engineering as you know it, right? Sometimes it seems like so. I'm not going to give you my own view right now, give to you some pointers, show you something, probably you will get you to your own conclusion. The idea of this talk started like a few months ago when Tommy wrote to me, and I really wanted to build it on the foundation of what we did here on stage last year. By any chance, any of you were here in my live coding session last year? Okay. Thanks for repeating. For those of you, last year I was doing live coding session, but with GitHub Copilot as an assistant to speed up the development. So something that I will not be able to do live coding in 20, 25 minutes, I was able with this help. But a few months after, and it is just a matter of months, we've came to a whole new world in which the AI is not just an assistant to speed up my work. It's really an autonomous agent to which I can delegate tasks while I just focus on something different, typically something which is more important. And as I elaborated that, my own personal journey into these agentic workflows, it somehow gave birth to this session. Well, I'm Jorge Hidalgo. The presentation was so nice, I'm not going to try to make it better, any better, that's impossible, no. But yes, 1 year is a lot of work. You have seen that a lot of times. We've seen in Max's presentation, then in Adam's presentation, the future is agentic. Even if agents in this new form are so new, they have this transformative, truly transformative power that we are seeing. It happens in all the, let's say, different strata on our organization, and of course, in software engineering. During Max's keynote, he has already showcased, what does it mean for software engineering, And in a nutshell, what we are trying to imagine is that our teams, which are currently a bunch of senior people, management people trying to organize the work and generating a backlog of the stuff that we need to do. And then we have a lot of software engineers, junior, mid-software engineers taking on those tasks. We are evolving, not today, not tomorrow, but this is near future for sure, in which those more senior guys defining, imagining, and creating the backlog of work are going to rely not only on human engineers, but also in agents. So this comes with a very interesting thing for all of us. Two things, actually. First, we need to know which kind of task we can delegate to the agent. Okay? Because, no surprises, they are good for many things, but there are other things that they are not good at. And we need to learn what kind of task we can delegate to an agent. And second, more importantly, we need to know how to work with an agent. I'm going to spoil you, they are not humans. We humans are very good at taking a very vague requirement, like a couple of phrases in an issue, in a Jira issue, and just fill in all the gaps, right? We know our business, we know the organization, we know the technology, we know the real world, and we fill all the gaps. And from those vague requirements, we create software. And sometimes we make bad decisions, that's why bad quality exists, that's why rework exists, but we're very good at that. However, the agent is not that good at that. We need to, let's say, take all our thinking process and codify it so the agent can take up the task. More interesting is that if I'm able to codify my thinking, I'm also able to codify what I expect as a result. And that's my favorite part, because even if we are speaking in natural language to the agent, we have translating a real-world problem into a codified statement, process thinking, and codified verification. That's code. That's code. I know sometimes this is frightening. We are too fond of our Python code, of our TypeScript code, of our Java code. But if we are able to codify the intention of a system and how we verify that the system is doing the right thing, that's code, even if it is natural language. Okay? So this means that there is no really a huge change, or there should not be a fundamental change of what does it mean to be a software engineer. How many of you know what this is? Video recording system. In the 80s, programming the video was a thing. You wanted to watch a program and you were not at home. You programmed the video recorder to start at this time, stop at this time, and record this program. And then you came home after, you take the tape, and you replay that program. That was a thing, programming the video. So obviously, software engineering is much more than just programming. Who knows what is this? Okay, quite a few. This is a punch card. It's how we, in the old days, transcribe a program into something that the machine could process. This is just one line of code, 80 characters. So you can see in the top the actual code. I think it's Fortran code. So compact, just trying to fit as much as possible of the program in just one line. Because when you were programming that, you needed to be so fast because you have like a limited time. You were allocating like 5 minutes with the machine. And in 5 minutes, you need to feed your punch cards. Hopefully, they are well encoded because every character has the different codes in there. So at some point, I can figure out when the first keyboards came into the mainframes and the PDP-80s and all this new wave of computers, some people will think, I no longer need to punch cards. My job is done. But, and this connects a lot with what Maxis has been presenting in the beginning, is like, it was not the case. Actually, the whole software engineering business grew because now we could do more with the same time that we have allocated, which means that we could do much more things than before. Nice machines with a keyboard, so you don't need to punch cards anymore. So just to finish this short introduction, I think that the key is that we need to continue putting more weight into the thinking and abstraction process and taking decisions, not so fond of code. And now we are going to see in action what does it mean to have an autonomous agent, okay? Because I will not be here if I'm just delivering. I need to do the live demo part, okay? It's going to be quite different to other years because I'm not going to do the coding part. So I'm kind of cheating. I'm not doing live coding. The coding part is done by the autonomous agent. But I really wanted to let you get a glimpse of how they work under the hood, how we can learn from that to be better software engineers in the sense that we are able to translate our intention into a clear task specification so that autonomous agent can do that. Okay? And for that, I'm going to use GitHub Copilot. Okay? There are a lot of different assistants and autonomous agents. I personally tend to use GitHub Copilot more, and specifically for this talk, the great thing is that GitHub Copilot is very open at how it works. It gives us all the internals, all the intermediate tasks, all the logs. So when I analyze these logs, I can really learn a lot at how this works under the hood. What's the process thinking of this agent? And that, I hope, is making me a better software engineer because I know I'm, let's say, better equipped to translate my intentions, the task, into something that is actionable by the agent. Hopefully, I'm going to show you this. Okay, so let's start from the beginning. And to me, the beginning is like, maybe I still don't have a task for the autonomous agent to do. But one of the interesting things is that I can also ask the autonomous agents to analyze source code. Let me understand an application. Or, as I'm going to show you here, I'm going to take a very old application, the pet clinic application from the Spring project. Hopefully you know about it. It's a very simple web application that tries to simulate a pet clinic when you just go and ask for an appointment to get your pet visited. Okay. It's very simple, but at the same time, it has all the basic principles of a web application. So services, REST interface, web application part, etc., etc. But there is something that I know. There are things that are missing in that application. So the first thing I've tried to ask the coding agent is, please analyze this application for me. Look for missing functionalities. I'm going to make it bigger. Look at the different services that this application has. Look at the REST endpoints that this application is exposing, and identify any missing functionality. So I have this concept like, this is not complete, but I really don't have right now the time, or maybe I think that I can delegate this into the coding agent. Actually, the coding agent is very good for this. LLMs are very good at taking huge amounts of data, correlating, finding missing parts, trying to make something consistent and identify what's not consistent. No? So that's good for that. So I created the task, and I assign it to the coding agent. For a few minutes, the coding agent started to work. Okay, I'm not going to do it right now because I don't want to have you waiting for these 20 or so minutes. But when it finishes, it created for me a very detailed analysis of everything that he has done and that discovered along the process. A README analysis with a summary of the things that it was found, a more technical deep dive with the creation, retrieval, update, and deletion activities that happen inside the system, a summary of the missing functionalities, and a visual overview of everything. Not sure about you, but in my opinion, this goes far and beyond what I would expect of any normal programmer working with me in a team. It has really done a more elevated view of what I ask, and it's actually very good. So it identified things that were missing, even showcasing me what was missing there, services that were missing, REST APIs that were missing, and created all this whole summary. And then, even if I didn't ask to do that, for it makes sense to also create an implementation roadmap. Okay, so going far and beyond of what I just asked, which was analyze missing functionalities, it also gives me a hint of what should I do next. I found these missing functionalities. Now I think that you could implement all these things to make this. It even did, and this is really nice, an estimation of the effort. 1-2 weeks for the code completion, okay? One question for you. How many time do you think that it took the autonomous agent to complete that? Between these 1 or 2 weeks?
20-30 minutes.
A couple of hours because I needed to do 4 tasks. But yes, you're right. 30 minutes per task. So it's funny because it's like, you human, puny human, this is what you will take to do that. You know, usually they are not that kind of, they don't interact with us in that way, no? But they could put like kind of an asterisk, no? I can do that in 2 hours. But that's reality. This is an estimate of really not using the agent. But it's really good, really good. So this is one of the first things that I learned is that I can use autonomous agent to also prepare things for me in the background. Not just dedicate to one specific coding task. I can also delegate part of the plumbing of the application and thinking on the things that I need to do along the way. Of course, technical things. If I try to ask the coding agent to translate a problem in the business, he don't have that information, of course. But for technical things, that works really, really nice. Okay, so let's look then at the next step, okay? So let's start implementing what is missing, right? So I ask, implement the update visit entity. Nice thing is that as I have the previous analysis, I don't need to provide any more information. Because, and it's also related with one of the previous keynotes, one of the key things of agentic AI is that they are not stateless. They are not just limited to short-term memory. They also have long-term memory. So in this case, I don't need to come up and copying and pasting from the previous analysis task to the new task. Like, mimicking what my fellow software engineer will know. It's like, in the second time, you remember what you did in the first task. So you don't need to come again with all that. So let's do this. Let's go into the detail. But I want to show you how this works. Okay, let's see if I can go there. Sorry. Let me look at the session. This is what I mentioned before that I really enjoy when I'm working with GitHub Copilot. And it's really, in these few months, helped me a lot to learn to use it, which is that I get this access to everything that has happened when this task is assigned until it is finished. So first thing that it does, it prepares a coding environment. No surprises, it's using MCP. MCP is, this protocol to connect agents with tools. Make something that is non-deterministic, because it's just natural language, LLM, into specific pieces which are deterministic, like create this code, like run these tests. And first is analyzing which files do I need to modify for this task I've been given. It's analyzing all the source code, so we can see that we have the view file, view file, view file. So it's really looking at the whole problem statement and identifying all the different pieces in my system that need to be modified. It's also looking into the database, which I didn't ask, I didn't explicitly mention, but as the agent knows that this is a program in the typical 3 layers, and it also has the information on the database schema, that if they need to do something on entity, they need also to take care of what's happening in the database. Maybe there is something that you need to change in the database. Okay, so what's the next thing it does? Really interesting, because when I was previously speaking about the process thinking, how we do our work, the coding agent is mimicking that somehow. So what I will do as a software engineer in this task, I will get the code, and I will run it locally before modifying anything. I will just run it and learn from it. So it does the same. And not just building the project, also running the tests, which is always a nice way of learning about a new project that I'm working on. I run the test, and with that, I get an understanding of what's happening, and more importantly, I know that the tests are good for me, like a baseline, to understand that I'm not breaking anything when I make my change. This really exploded a bit of things in my head, because at this moment I started to realize that in some sense, the coding agent is better software engineer than we sometimes are. They are more disciplined. They follow all the process. All the time, we like to rush and take shortcuts, and we are not always completely, let's say, consistent with the software development process. But the agent is, and it's taking all the right steps, like getting the projects, looking at the code, building the projects, running the test, etc. Of course, now it begins with the actual modification process. And one of the good things that it does is that for every change it does, it's running the tests. Again, discipline, something that we sometimes have forgotten. No? It's like, if I'm modifying something, I need to test that this is working well, and at that time not breaking anything. So this continues to this process until it'll, let's say, complete the modifications, okay? At that point, it decides, I have completed my task. So it's the moment to report the task back to the human that assigned it to me. This is another thing that I'm starting to see that the coding agents are really excelling at. Much better than we do, which is explaining what we have done what we have achieved, or even if there is something that goes wrong, and I will show you now an example to show that. So it's a very detailed explanation of all the tests that I've run, verifying that this has worked. So it's really, really detailed. And of course, the code is very good. So if I go back, if I go back and I look at the files that have changed, I can see that it has done minimal changes, chirurgical, just the specific change that I asked. And in this case, you can see that it respects the style of the original application. So this is probably not a best practice nowadays. But as this application is so old and it uses directly SQL queries, it is creating the new functionality respecting that technology decision. And this means creating the SQL queries that were missing in the code. Again, this is something that we can ask differently, but I think that's like a very good decision in terms of implementation, not to break what is already there, try to blend my new code into the code that exists. Okay, so this is one example. But I wanted to also show, well, I also implemented the delete visit, etc. No? But I also wanted to show you another case that sometimes it didn't work completely. In this case, I'm taking a very old Java library that was in Java 8, and I ask the system to move it to Java 17, along with all the dependencies that it needs. Well, I'm going to spoil you. This task that I assigned the agent, I did it before, a few years ago. So I, as a human software engineer, I already faced this task. I know that it took to me like a couple of days. But most important is that I was not able to finish the task the first time because I found an incompatibility when doing this change. Do you know what? The autonomous agent also found that incompatibility and was, I will say, with good criteria, decided at that point to finish the task and say to me, this is all the things that I have accomplished. I have updated these dependencies. For example, it was good enough to identify that in all these years, the Java enterprise have moved from Java EE to Jakarta EE and make all these updates. I don't ask for that explicitly. It was found out. All the versions, he does that automatically. The same that we will do. Let's go to Maven Central, look at what is the latest dependency for the latest version for the dependency, and use that in the code. So replicating the same process that we will be doing, I don't need to instruct every single version of every single dependency. It's going to find them. Another interesting thing, the great change that I had during this time was the Bouncy Castle cryptography library. It's a very dense and complex piece of software. And they made changes to make things better. That took a lot of these 2 days for me. Discovering the new changes, the new interfaces, the new structure. It was really painful. I remember still that. For the agent, it was very natural. It's good at that, no? Identifying the changes, making the changes in the code, just to ensure that I move from the old structure to the new APIs and make that everything works. And as it has all the unit tests, just ensure that nothing breaks along the process. But there is a problem, as I mentioned, because at that time, there was a library that was still not completely adapted to the new Java version. So there are some tests that fail. But instead of just trying to do something nasty, like I've seen in other agencies, like the test doesn't pass, I modify the test. I've seen that, and we need to be always careful about that, because these are LLMs. At the end, they want to be so complacent to us. They always want to be right, and they always give us all the right questions, all the right answers. Sometimes they may cheat a bit, no? Not in this case, no? This is not working. This is not working for this, and this, and I really don't know how to proceed. That's what I will expect to a companion software engineer. I've been able to get to this part. I don't know how to proceed further. Help me in completing that final part of the assignment. But the rest is very well documented, and the code is is really good at that. So, as you can see with these examples, well, I'm going to show you something, which is at the end. I want to go to the session. Here. Because as I mentioned, we can see all the internal details of how this works, okay? So Wi-Fi, so the connection is okay. So again, it created the development environment for working, okay? Identify the repository, how it is configured, how it is built, checks the Java version, okay? It checks, which is interesting, as I'm asking to go up to Java 17, first it checks, do I have Java 17 to work? It checks it, it found it. And it starts making all the changes, etc. Okay? So, as you can see, there is a lot of process here, a lot of process I'm thinking about. Sorry, not really thinking, it's like, this is mimicking the way that we work as a software engineer. But there are a lot of tasks, and this is one of the important aspects of agentic AI. This is not an assistant that is doing this piece, respond. Next piece, respond. That was last year's talk. This is doing all these things autonomously. I don't need to be instructing step by step everything that is happening. And it's quite complex, as you can see. Dependencies, it works. Changes in code, it works. Changes in the test, they work. Finding the right environment, it works. So it's really, really complete. I'm going to just go to the end because that's what I wanted to share with you. As you can see, it starts to make all the changes and testing, everything is still working. And as I mentioned, sorry, I cannot see it right now. It's lost in the middle. But well, anyway, no problem. We've seen that in the other screen. It identifies which tests are missing and say, I cannot fix them, and go back to the previous. Okay. But now kind of the last example I want to show before going to conclusion, question, and answer is that how far we can go with this, okay? As I mentioned at the beginning, there were two things that I think are important for us as software engineers as we adapt to work with autonomous agents. One is how we ask the tasks, no? How we describe what we want to achieve, how are we going to determine that the result is correct, okay? That is one part. And the other part, you remember, was understanding which kind of tasks I really can delegate. So this really has improved, even if it is just a few months' time, this has improved a lot in just 6 months. So this task I assigned yesterday, a couple of months ago, didn't work. So this is for you to kind of realize how fast this is moving. That in weeks, we are seeing significant big steps into this process thinking that we are having into autonomous agents. So in this case, I got this preclinical application that we analyzed before. It's very old, Java 8, all patterns, SQL queries, you've seen that. And I ask it to add support for Java 25, so the latest version. And I carefully selected these words, add support. Do you know why this is important? No? Any clues? No?
It's not revealed whole project.
Right?
It's not revealed whole project. Not revealed the whole project.
Sort of. It's like, I don't ask you to just upgrade to the new. It's like, you need to be sure that it works with the new and also works with the old. Because it's adding support, not upgrading and forgetting the old things. So it's a bit more complex. And you know what? It did it. One of the interesting things that it started is that it documents the whole process of what are the things that need to be done. And one of the things that really blew my mind when it started is that, as we were discussing, is like, okay, you've asked me to add support, so I don't need to forget the previous version. So I probably need to add this matrix job in which I will test in every possible version. So something that really was recently surprised that it got that, let's say, detailed stuff in the request. Let's see what's happened. Well, you can see that when we assign a time, always the agent creates a pull request, and it does it at the very moment that it happens, which means that it's documenting the process as it happened. I'm going to show you that. Okay, so I'm going to come here, and I'm going to create a new issue, and I'm going to say, add support. We are not going to wait for the end. I will show the other, but I want to show how this starts. So let's add support for Java 25 while we are live demoing in OpenSlava conference. Okay, yes. Why not? So let's assign this to Copilot, and let's start with the task. Okay. So as I was explaining before, one of the great things of this kind of agents, and I will say much better than we as software engineers, is that they immediately start reporting what they are doing. And they keep this live every second, every minute. So we can always go to the agent, see what is the plan of work, what are the individual tasks, how far it goes, if has been any problem so far. So it's kind of a continuous feedback loop with the agent. Even if it is autonomous, I can go anytime and see what's happening under the hood. Okay, so we can see that already Copilot took that and created the work in progress pull request. So as a work in progress pull request, as I explained before, this is going to be constantly updated. Right now we have just the original prompt, but as this progress, it's starting to get enriched. We will be back here so you can see that, but I don't want to have you waiting. So that's why I'm going to come back here and go to the complete one. Okay. So what the agent was able to complete. Look, it was able to update all the different dependencies. So the actual project and dependencies, the Docker file for running this application in a container. It was able to update also the Jenkins file when we have the CI/CD pipeline. As this is a project I use for a lot of demos, I have Jenkins file with the CI/CD pipelines in Jenkins, but I also have GitHub Actions for the equivalent in GitHub. So it updated both of them, okay? And then this is all. I don't use it anymore, but I used to run this application in the Heroku cloud. So I took also the properties that are needed for that and also updated. Updated the documentation, updated the tutorial, and created a detailed file with everything that has upgrading. Again, something that I think that the autonomous agents are better than we somehow, is that they tend to document with much more detail and much thoroughly than we do. Which is also great, because we can then use this documentation for the next batch of changes and evolutions. So knowing that the system is not only able to do the tasks, but also document them very well and enrich what we have as the knowledge base of our applications is also a very nice addition. No? It compiled everything, it works okay. It ensured that everything is still packaging well. It ran the Docker image to ensure that it's okay. I mean, there is a lot of things happening there. Modifying the code, running the text, packaging the application, deploying the application, running it as a Docker container. There is a lot of things happening without me needing to instruct in a detailed way all these things. There's a known issue with the ASM library, but I know that they are trying to work in that to support Java 25, so I'm sure this will work surely, but the rest of the changes completed perfectly. So at that point, and now starting to come up with some conclusions, and then the questions. And trying to summarize what we've seen is that, first, sometimes it frightens me, because I see a lot of power in there. But, you know, I understand, and I speak with a lot of the people in my teams, etc., and the clients, and we are too fond of the code that we produce. We are still probably not ready, but this is going to happen not tomorrow, not the next month, but maybe in 1 year, 2 years, this is going to be the reality that we're going to be facing. And you know, I think it's good. Because in the times of the punch cards, to create just a simple program to create a mortgage table took months. Something that we can now do in minutes. But it took months, because you needed to write the program in paper. You needed to test the program in paper. When you were sure that this was the right program, you punched the cards or type in the PDP. But everything was done in paper. Programmers didn't have computers to do the work at that time. And you know what's happened after all this first revolution that we have in the industry? That the same people were able to do more. And when I look at the clients we work with, the reality is that there is no single client that does not have more projects to run. Our clients always have a lot of things to do that they cannot because they don't have the budget, the time, and the people to do that. So projects start to get deprioritized, forgotten, cornered, because simply speaking, we don't have enough resources, man and machine, to do all this work. And now I think, and this is the great opportunity for us as software engineers to not only increase our level of abstraction, but also to increase the impact we have in society, which means that our clients with us will be able to get all this bunch of projects that never get light and now be a reality. Because we will be able to do much more with the same time that we have. So, finalizing this, before going to the questions, last message, and this connects a lot with Max this morning, is like, I really think that it's not that we are going to lose all our jobs, okay, all of a sudden. It's more like we are going to see more and more software engineering work coming down to us, okay? And of course, we will have this ability to take much more work than we can today. My own take, okay? Is this the end of software engineering as we know it? For me, yes. For you, well, let me know, okay? So, any final questions that you may have? And thank you.
Round of applause. Okay, we're going a bit over time because people want to switch, but I do want to give you one question. So, pop the Slido up real quick, and let's do one. That we still have the time. Where's the Slido gurus? There we go. You can pick one, and that will be the golden nugget that you can end with.
Okay. I will start with the second one, because this is one of my favorites. Okay? Since I was a child in software engineering, I has been always told something that I think is very wise, and I try to get always living by that, which is, you delegate the task, never the responsibility. There is no difference with AI.
Okay.
Just that.
Boom. That was the. Give him a round of applause. Jorge Hidalgo. If you have the questions, he will be around all day. Thank you so much.
Thank you very much.